Okay, so we're just going to go over the different types of characteristics for zero order, first order, and second order reactions today. So let's start off with the zero order rate law, which is just going to be rate equals k. And k is the rate constant. So what this is basically saying is that it doesn't matter what the concentrations of the reactants are. It's just that the rate of the consumption of the reactants is going to be the same until all of the reactants are consumed. So what the graph looks like is we have concentration of any reactant, let's say reactant A, on the y-axis and then time on the x-axis. It's going to look like a line with a negative slope, and we can use the integrated rate law to describe this graph. So what the integrated rate law for a zero order reaction looks like is concentration of A, at a specific time, equals initial concentration of A minus KT. So the initial concentration of A is going to be the y-intercept, and slope is going to be negative K. Okay, so let's move on to first order reactions. The rate law is going to be rate equals K times concentration of A. So this is first order because technically the exponent for this would be 1. So to find the total order of the reaction, you would just add up all the exponents. And so it's just 1. Now the graph looks pretty much similar to a zero order graph, except on the y-axis you have the natural log of the concentration of A instead of just concentration of A. Then we also have time on the x-axis. Now for the integrated rate law, we have concentration of A at a particular point equals natural log of concentration, or initial concentration, minus KT. So then on to second order, we have a rate law that can either equal K times concentration of A squared, or K times concentration of A times concentration of another reactant B. And this still makes sense because if we put in the 1's, we get 1 plus 1, which is 2. This is just 2, so they're all both second order. Now the graph looks like this, with the reciprocal of the concentration of A on the y-axis and time on the x-axis still. But this one is going to have a positive slope. And then the integrated rate law is going to be 1 over concentration of A at any specific time equals 1 over initial concentration plus KT. And this is going to be positive because we now have a positive slope. So it's actually not that bad to remember. They all have the same basic pattern in their integrated rate law. It's just concentration of A at any specific time equals initial concentration minus KT or plus KT if you're second order. And then for first and second order, you can just apply the natural log transformation or the reciprocal transformation onto it.